In this video, I am going to use the second derivative test to determine whether the function f of x is equal to x squared times e to the power negative x has a local maximum or a local minimum. But before I do that, let me explain to you what is a second derivative test, what it entails. So let's say you have a function f with the following property. Second derivative for f exists and it's continuous. Second derivative is continuous in some neighborhood of c. In some neighborhood of point C. Okay? Now, conclusion number 1. If f prime of C is equal to 0 and f double prime of C is greater than 0. So pay attention to this. F double prime of C is greater than 0 means it's concave up. Concave up. Then f of C is a local minimum. Okay? Is a local min or minimum. Conclusion number 2, again, if f prime of C is equal to 0, but this time f double prime of C is less than 0. Remember, if f double prime of C is less than 0, is concave down. So if these two conditions are satisfied, then f of C is a local max. Local max. So what we are going to do here is take this second derivative test and apply it to this function. Once again, just to summarize quickly what is second derivative test. You have a function f, right? You have a function f double prime is continuous in some neighborhood containing C. Okay? If f prime of C is equal to 0 and f double prime of C is greater than 0, then f of C is a local min. And f double prime of C greater than 0 means it's concave up. Similarly, if f prime of C is equal to 0 and f double prime of C is less than 0, that means it is concave down, then f of C is a local max. So now what we are going to do, we're going to go ahead and take the derivative of this function. So let's go ahead and take the first derivative. F prime of x is going to be negative x squared times e to the power negative x. So u times derivative of v plus v times derivative of u. V is e to the power negative x, right? E to the power negative x times derivative of x squared is 2x. So f prime of x is going to be e to the power negative x, okay, times x. So I could factor out another x. So that's going to give me 2 minus x. Now, if I set it equal to 0, I'm going to get the critical points. Set it equal to 0. Please note that e to the power negative x is never equal to 0. So it means that x times 2 minus x must be 0. So that tells me x is equal to 0 is a solution and x is equal to 2 is another solution. So that means these are two critical points. X is equal to 0 and x is equal to 2. At this point, I just take the second derivative, which is very straightforward. I have the first derivative and I go ahead and take the second derivative, and this is what I get. So I need to evaluate this second derivative at the critical points, x equal to 0 and x equal to 2. So let's do the point 1. That's okay. X is equal to 0. We know when x equal to 0, f prime of 0 is 0, right? So we have f prime of 0 is going to be 0. And what about this guy? x equal to 0 means this is going to be 0, this is going to be 0. E to the power negative x is always positive, right? So that's going to be positive, and 2 times a positive number is positive. So f double prime of 0 is greater than 0. So according to condition 1, this one, f prime of c is 0, f double prime of c is greater than 0, so it must be a local mean. So at x equal to 0 is a local mean or local minimum. Now let me go ahead and evaluate the other point, number 2, when x is equal to 2. What happens? Of course my f prime of 2 is equal to 0, because that's how I found these critical points. What happens to the f double prime? So in this case, what I have is 2 square. So 2 square is 4. 4 times 2 is 8. So negative 8 plus 2, which is going to give me negative 2. So negative 2 times e to the power negative x, which is always positive. So it's going to give me a negative number, because this x square minus 4x plus 2, it evaluates to negative 2 times e to the power negative x is going to be less than 0, because e to the power negative x is always positive. That tells me that f double prime of 2 is going to be less than 0. So now let's look at the second derivative test. You can see here, if f prime of c is equal to 0, f prime of 2 is 0 in our case, f double prime of c or f double prime of 2 is less than 0, then f of 2 or f of c is a local max. So our conclusion here is that x is equal to 2 is a local max. So just to summarize, what did we do? We talked about the second derivative test, okay? What it entails, the conditions for finding the local max and local mean, which is if f prime of c is 0 and double prime of c is greater than 0, then it's a local mean. If f prime of c is 0, f double prime of c is less than 0, it's a local max. We took these ideas and applied it to this function. We found the first derivative to find the critical points 0 and 2, x equal to 0 and x equal to 2. Then we took the second derivative and evaluated the second derivative at those critical points x equal to 0 and 2 to find out whether second derivative at critical points is either greater than 0 or less than 0. And based on that, we went back to the second derivative test and figured out whether the point in consideration or the critical point in question is a local maximum or a local minimum. I hope that this discussion was helpful. Thank you very much.